Let's say we have a project that will cost $100,000 today. We expect that it will result in cash flows of $22,000 per year for the next 6 years. Our stakeholders are expecting a return of 12% of their investment. Should we take on the project? And the first thing I want to do, though, is put a dollar sign in front of that $22,000 so that it looks a little bit, so the formatting is better. All right. Now I've worked this ahead of time just to save a little bit of time in the demonstration. Here's how I'd approach this. Should we take on the project? And I'm going to evaluate it using NPV, IRR, MIRR, and Payback. First thing we do is we lay out the cash flows that we know. So if I highlight all of these and change the color to black, again I've worked this ahead of time, we see the cash flows. $100,000 goes out of pocket the first year. Then we have $22,000 of cash inflows, which we reflect as positive numbers in all the remaining years. Okay, the interest rate is 12%. All right, let's calculate NPV. And I've done this ahead of time, but why don't I delete it and I'll show you how we calculate that. So here's what I'm going to do. I'm going to type in equal NPV, and then I'm going to hit the formula bar where we'll get the Excel's function arguments pop-up window, and we'll just reference where the information is. The rate is 12%. Okay, and then we give it the values. Now notice that I'm starting with the end of the first year, not the initial one, because that's what Excel is looking for in the NPV function. It tells you equally spaced in time occurring at the end of each period. Okay, when we're done with that, that's not the correct answer. That would be the present value of the cash outflows, or the cash inflows, excuse me. So then we have to add in the cash outflow, and since I've entered it as a negative, we just reference it. You see I'm adding the formula down here, or you can see up there. And so NPV turns out to be a negative number, which means it's not something we should take on. Oh, by the way, you can also format the interest rate as a percentage and it will work just fine. Okay? Now, internal rate of return, I'm going to delete that, bring that to light, and I will solve that one too. Internal rate of return, it's an IRR function. If you type in equal IRR left parentheses and hit the function bar, you get the pop-up. Now with IRR, it just wants to know the constant time frame payments. Okay, and since ours are in annual buckets, we just reference all of those, and then it wants a guess, and I tend to use 10% as a guess. And when I do that, I see that the IRR is 9%. If I take it to one decimal place, it's actually 8.6. Why don't I take that one to one decimal place as well? Okay, then we can use the modified internal rate of return, which is like the IRR, only where the IRR assumes that any cash flows are reinvested at the IRR rate. The modified internal rate of return allows us to determine what the rate is, and we'll use the 12%. So in a lot of ways, MIRR is a superior technique. Okay, so the values again, we type all of those in there. Now here I'm not hitting the pop-up. I can just use the screen, the little pop-up screen down here to tell me where it goes. Okay, the finance rate is 12% and the reinvestment rate is 12%. And that way we've reflected the proper interest rate given in this problem. And when I close that, I see that MIRR is a little bit better, 10.1%, but it's still below the expected rate of return our shareholders expect, and that's why NPV is 0. Keep in mind that by definition, internal rate of return calculates that rate where the NPV would be equal to 0. Now, just to explain that, if I type in 8.6%, NPV should go to 0 or close to it if it's not 8.6 exact. And sure enough, we're down to $121. So if I made it, 8.61, but if I get it in the right decimal point here, or 8.5, I mean, 8.58, we're going to get closer to 0. Okay, but let me set this back to 12% so we can see how we evaluate this. And then finally, we do payback. Now, the way I like to do payback is to just actually look at it. I'll come up with the cumulative cash flows, and then what I'll do is enter this formula where I'll say that's negative 100, and I'll enter one more formula, which is take the cumulative amount plus the current amount and come up with what that would be, and then copy it down. Okay, now I don't need the dollar sign on all of these, so let me format that. And then what you see is we're negative off the bat. At the end of 1 year, we're still 78,000 in the hole. 2 years, we're 56,000 in the hole. 3 years, 35,000. 4 years, 12,000. So somewhere between 4 and 5 years, we have the payback. Now, let me show you how I solve that. Using the formula, what I take is 12,000, but I flip the sign, right? So I say 4 years, because I know that's when we go positive sometime after the 4th year, right? The 12,000 is less than 22. So I subtract D9 so that it's a positive number. 12,000 is a percentage of 22,000. Tells us what the payback would be. Now, the approach I've used here works when the cash flows are not exactly the same. By the way, if they're exactly the same, this approach works, where you simply take the 100,000 and you need to flip the sign, right? Because you want it positive, divided by the annual cash flow. And I come up with the same answer. All right, well, based on all of this, what do we know? Should we take on the project? Since NPV is negative, the answer is no. The other way to evaluate this is both the internal rate of return and the modified internal rate of return are coming up with an interest rate that is lower than the expected rate of return that our stakeholders are looking for. Payback says it's going to take 4.5 years before we get our money out of this. That seems to be a fairly lengthy time given the cash flows. But quite frankly, I would not rely on payback as an approach to determine whether we should take on a project or not. I would use NPV or MIRR. Those would be my two preferences.